We're going to look at graphs of exponential functions today. We're going to look at what they look like. We're going to do some graphing ourselves and look at some domain and range problems. So, exponential functions, exponents. We've worked with exponents before. A function of the form y equals a times b to the x. So you got a, which is kind of an initial amount. P, which is a growth factor. It's not going to be equal to 1, and in our case it's always going to be greater than 0. That's going to be our exponential function. So you see a couple examples here. You have exponential growth here. We're going to have two things. Exponential growth where it gets bigger, and here's exponential decay. It's getting smaller. Notice it forms what we call an asymptote with the x-axis. It gets really, really close but won't touch. And notice all of them have an a value of 1, so they all go through this point 0, 1. So let's graph an exponential function. So we're going to start by making a table of values for -2, -1, 0, 1, and 2. So we're just going to type it into our calculator. It's 4 to the x, so 4 raised to the -2nd power. And then we get 0.0625. So that's a pretty small number. 4 raised to the -1st, 0.25. 4 raised to the 0, which is going to be 1. 4 raised to the 1st power, which is going to be 4, and 4 squared, which is 16. So exponential growth, you see how it's growing really fast. So at -2, it's real small, just above 0 there. At -1, it's still real small, quarter. 0, 1, set a point there. 1, 4. And it shoots way up at 216. So we can't use our calculator a ruler to draw this line. We gotta freehand it a little bit. So again, it doesn't go below this x-axis, so it stays really close. It goes through these 2 points, and then here it will shoot up really fast. So we have an exponential growth function. So use your calculator to evaluate y is equal to 4 to the x when x is 1.5. So 1.8. 4 raised to the 1.8, that is 12.12. What we can do is then go back to our previous graph we checked and see how close that is. Go where x is 1.8 and see that it's at 12.12. Now the domain and range. Domain, remember, as possible x values. Range is possible y values. So notice we can plug in any x we want. So domain is all real numbers. So you can write the R with 2 big stalks or put all real numbers. Either way of writing that. And our range is the possible y values. Talked about an asymptote earlier. It will not go below the x-axis. So y will always be greater than 0. So the domain of our function is going to be all real numbers. The range is going to be y is greater than 0. So here's another function, and let's go about it a similar way. Let's make some values. Right. So let's pick x values and get y values. So let's start with -2. At -2, that's something that's going to be off our graph. So negative 2, 32. Notice the b value, the one in front of the exponent, is less than 1, so it is going to be exponential decay. So if we put in negative 1 here, so 1/4 to the negative 1, or I'm using 0.25 to the negative 1, is 4 times 2 is 8. So negative 1, 8. If we plug in 0, 1/4 to the 0, anything to the 0, remember, is 1, times 2 is 2. If I plug in 1, 1/4 to the first power, 1/4 to the first power is 1/4 times 2 is 1/2. If we plug in 2, 1/4 squared, or 0.25 squared, see, 0.25 squared times 2 is 0.125, which is 1/8. Right? So if we plot those points, we'll skip the negative 2, 32, because that one's going to be off our graph, but negative 1, 8. So you see how fast it's going to fall. It's going to start way up here, fall to 8, and then cross here at 0, 2, 1, 1/2, and then 2. It gets really close to the line there. So it's going to fall really fast, and then it's going to level off and then form that asymptote, get really close to but never touch the x-axis. Domain and range are going to be similar here. The domain, we can plug in any x values we want. So domain possible x values is all real numbers. The range is going to be y is greater than 0. It stays above the x-axis.